Okay, we are picking up where we left off yesterday in lesson 2.7. Ready for the back side, right? On the front side, well, the whole lesson is linear quadratic equations, right? Or systems. So on the first thing when we're graphing, it's where does that parabola and that line intersect, right? Then we quit graphing, we did substitution, we solved them algebraically. I don't know what you guys like better, probably depends. Probably the algebra there. Now, on the back side, first thing we're going to talk about is inequalities. So we're back to graphing. And with inequalities, remember it's solve each system of equalities, and we're going to be looking at the shading. Okay? The graphing is not too bad on these. Honestly, we did the worst of the graphing yesterday. Okay? This graphing will work out a little bit nicer. So let's start by graphing y greater than x squared minus 4, which when we go to graph that, for the moment, drop the inequality sign and just think, okay, how do I graph y equals x squared minus 4? So what do you know? How do we graph y equals x squared minus 4? No, not to graph it. Maybe if we're talking solving. What is y equals x squared? Y equals x squared is a parabola. What's a minus 4 do to it? Well, a number added or subtracted at the end is up or down with the direction of the sign. So a minus 4 is actually going to take it down 4. So the nice thing about this one, let me write this, down 4. Yesterday, on the front of the page, we had parabolas that were ax squared plus bx plus c. There's that bx term. Because there's the x term, we had to use the axis of symmetry. X equals negative b over 2a. But today, there's no b. Because there's no b, it's just x squared. You can take that x squared parabola graph, move it left, right, up, down, whatever we need to do. So we're going to take the x squared minus 4, and we're going to move it down 4. Keep in mind, what's a basic parabola look like? Basic parabola has points. Yeah. If the vertex is 0, 0, then use 1, 1, and 2, 4. So, let's go ahead and graph our parabola. Down 4 means I'm going to count down 4 units from the origin. If that is my vertex, then from that vertex, my first set of points will go over 1, up 1. So I'm going to go right 1, up 1. I'm also going to go left 1, up 1. My second set of points go back to the vertex. We'll go over 2, up 4. So right 2, up 4, left 2, up 4. Now, I would pause before you connect those. And think about what kind of questions we have to ask ourselves since we're working with inequalities. Where to shade, but before we talk about where to shade, there's another question.
Isn't it like if it's dotted or like a solid line?
Yeah, do we use a dotted or solid line, or dashed or solid line? Why? Yeah. Remember, if it's not equal to, we're going to use a dotted, or I usually said dashed line. I don't care what you think. But, so if I say, I'm going to write dashed, and dashed is because it's either a greater than or less than symbol. It's not equal to. Now, I will say, doing this with a parabola I decided this morning is kind of difficult. Your parabola looks something like that, right? It is a dashed or dotted line. And again, it's because it wasn't equal to. Then, after you decide whether it's a dashed or dotted line, now we're going to ask ourselves, where do we shade? Where do we shade? Choices are above or below. Above. And we are going to shade above anytime it's any type of greater than sign. So greater than or equal to, we're going to shade above. Now, above this parabola is where? above this parabola ends up being inside of the parabola. That means below this parabola would end up being on the outsides of it. Okay? We didn't do this with parabolas in chapter 1, but we did this with lines in chapter 1. Yes? Does it sound familiar then? It's just we're now throwing in the parabola twist with it. We also need to graph our other inequality. Y less than 2. Now, again, in order to graph y less than 2, my recommendation is, okay, forget the inequality symbol for a moment and ask yourself, how do we graph the line y equals 2? Any thoughts? Again, you have to dig deep, don't you? We graphed this in chapter 1. If it's y equals 2, that means it has to touch the y-axis at 2. And I don't know if it would help or if it's more confusing, but you could also think of this as 0x plus 2, right? But the key is if it's y equals a number, it touches the y-axis at that point, so it's going to touch the y-axis at 2. And then, yes, draw a horizontal line, because it's every place that y is 2. So at 1, 2, at 2, 2, all of those places. Now I'm going to pause before I draw my horizontal line, because we didn't talk about what type of horizontal line to draw. Okay, it is a less than symbol. It is not equal to, so it is a dotted or dashed line. Okay. Where do I shade? Okay. This one is a less than symbol. And anytime you have any type of less than symbol, whether it be less than or equal to, we're going to shade below. Below, of course, is below the line. Now, I'll be honest and say I didn't practice graphing these in your homework, so I can't 100% speak for what you will have to do in homework when you graph this. But if we recall from first chapter, you didn't get to graph the individual shadings, did you? I think you just graphed the final shading, maybe. So, and this is on a paper quiz or test for me, I want to know, okay, where do they overlap? Like, make it obvious to me. So where do these graphs overlap? In the bottom of the parabola there? The bottom of the parabola that is below the horizontal line? Make that so I can tell you understand that is your final answer. Okay? My assumption is that you probably won't be able to graph, the first shading, the second shading. You just have to look at where they overlap. Now, I do think, at least one of these, they just gave you a multiple choice. And you have to pick which one is the final graph type thing. But I think you probably have to graph at least some of them too. I don't remember exactly. Okay, questions here? That's technically all old news, isn't it? Just kind of putting together in a new form. Okay, let's talk about B then. Let's practice again. First graph is y greater than or equal to x squared plus 1. And again, I forget the greater than or equal to for a moment. My brain just wants to think, okay, how do I graph y equals x squared plus 1? What is that? Parabola that goes where? Yeah, up 1. Again, a number add or subtract at the end is just up or down that number. So up 1, and it's a basic x squared, and as long as that a value is 1, as long as it is 1x squared, we can use that basic idea that a quadratic is 0, 0, 1, 1, 2, 4. Okay. I'm going to move my vertex up 1. From my vertex, my first set of points are going to go over 1, up 1, and over the other way up 1. My second set of points from the vertex, go back to the vertex, over 2, up 4. Over 2 the other way, up 4. How should I connect these dots? Okay, this time it is greater than or equal to, so traditional solid line. Any type of equal to's, so whether less than or equal to or greater than or equal to, is going to be solid, so regular everyday parabola. Where would you like me to shade? Yeah, we have a greater than symbol. So that's going to be shading above. Any type of greater than will take us above. Above this parabola, again, is inside the parabola. Below the parabola would end up outside in this case. Now, what if my parabola was upside down? Then below it would be inside the parabola, but above it would be outside the parabola. Okay. Okay. We also have our line. Y greater than or equal to negative x plus 3. So I'm going to think y equals negative x plus 3. What do we know about graphing that? Yep. Y equals mx plus b is exactly what you need to think. My y-intercept is b, which is 3. My slope is my m value, which is, what is my slope? Negative 1. And negative 1 is a fraction. It's negative 1 over 1. So, y-intercept of 3. I'm going to count up 3 on my y-axis. A slope of negative 1. I can go rise negative 1, so down 1, run positive 1, right 1, down 1, right 1, down 1, right 1. Or you can reverse it. We can go up positive 1 and left negative 1. Up 1, left 1. Man, those would be nice, easy points if we needed to know those intersection points, wouldn't they? I just landed them both, but I don't need to know those. Okay, what kind of line am I drawing? A solid line? Yep, because it is equal to, again, a solid line. And where am I shading? Above. It was greater than. So any type of greater than tells me to go above. Where's our final answer? Okay. In that parabola again, but this time it's the top part above in the parabola, right? So it's in the parabola above where that line goes through the parabola. I still don't like how the shading looks on a bin cube. It just looks so sloppy to me, but I definitely like it on my paper better. Much prettier. Okay. I tried to as we went along, you know, I kept putting when we were solid, above, below, dash, all those. I kept putting what type of signs would make us do each of those things so we'd know. Okay, questions there? Okay. The bottom of the page, it says using a system to solve an equation. Notice there's only one equation given in A and one equation given in B. And it says to solve this equation by writing a linear quadratic system of equations and solve it using, officially it says using the intersection feature of a graphing calculator. We're actually going to use Desmos to do this. Okay. But several of our standards in algebra and all the math classes say to incorporate technology. Okay, incorporate graphing technology. So being able to graph on something other than just paper and pencil is something you're expected to know. So let's look at these. First of all, about how we break them up. And the fact here that, okay, it wants us to write a linear quadratic system. Basically, this is set up where one side is one equation. So one of the equations I'm going to be graphing is the left, y equals x squared plus 9x minus 5. And then the other equation I'm going to be graphing is the right, the linear part. So y equals 4 minus 3x. Now, officially, we could do this by hand. It would not be pretty. Officially, we could solve this equation by making it equal to 0. We'd have to use quadratic formula, and that would be doable. But they're asking us to use technology. So get your iPads out, and let's hop into Desmos. We used Desmos earlier this year, right? So it shouldn't be too much of a surprise. Remember, go to Graphing Calculator. In your box, you're typing in the pieces. Remember, on here, you have to start with y equals. Okay. X squared plus 9x minus 5 is my first one. Then create a second equation. And y equals 4 minus 3x. Get those typed in. And by the way, you could do this on a graphing calculator. And I can show you how to find intersection points there. Honestly, it's a little more difficult to find intersection points there. But it can be done on a graphing calculator. We just don't. It's not something I require you to have, as I don't require you to have a graphing calculator. And I don't have a classroom set. I will eventually, but I don't yet. So, okay. Now, when you get there, if your graph is like my graph, it's really zoomed in. At least this is how mine was this morning. It was kind of more zoomed in. And so you really need to work on zooming it out so you can see the whole thing. In terms of, if I have a parabola and a line intersecting, how many places are they most likely intersecting? Most likely 2. Okay? And that's what we need to look for here, is 2. So if you can't see that, you might have to zoom in or out to make it happen. So, remember, you can see the intersection points, and this is the part that's nice in Desmos, is you can just tap on them, and you can get those values, right? Now, I learned this in a difficult way this morning. I misled my morning class, so you guys get the benefit of they had work time. We figured out my error. When you look at the equation on the paper, okay, my first thought is that what do we need to give? 2 ordered pairs, yes? But look at what the original problem was. The original problem was one equation that only had what in it? X is in it, correct? Okay. all that you need to know here for your solutions are your x values. Okay? And in homework, you'll just list them as one x value, comma, the other x value. You don't actually need the y values here. Does that make sense? Okay? You only actually need the x values. And that's because if you look at the original equation in the homework or in the notes, it was just in terms of x. So let me go back to my notes here. Everyone got their Desmos graphs to work? Okay. So the idea is, and this is just a rough graph here. We need those two, yes? But we only need the x values. So what x values did we have? 708 and, or 0.708 and negative 12.708. Only need the x values, okay? So we just want to know x values only. And again, this is because of the type equation you're solving. When you enter these in Desmos, they're already going to have x equals, and you just have to type them. It does want them to 2 decimal places, I believe, nearest hundredth. So 0.708, I would list as 0.71. Then you put a comma between your values. Negative 12.708, I would list as negative 12.71. That is what homework will look like. Okay? Okay. If you haven't, try B. See what you can come up with for B. You're going to graph your quadratic. Y equals 3x squared minus 7x plus 4. We're going to graph our linear. Y equals 9 minus 2x. You have a similar type thing happening again where it is 2 intersection points. Are you guys doing that on Desmos? Or did you already do it, one of the two? Your x values match my x values when you're ready to look. If they don't match mine, you might check and make sure you typed in the right equations. No typos there. You also might check and make sure that you tapped the right points. Okay? So when I enter this, I would say x is 2.37, comma, negative 0.71. Okay, guys. Your homework is in Savvis. iPads are out, so get working on it. It will be due Monday.